Course 1, Lesson 32 is about a couple topics that aren't really related, but both important that we are feeling confident on. Expanding our notation, not standard, but expanded notation. So showing numbers in a longer, more spread out expanded version. And then also elapsed time to remember. Let's talk more about that when they get a little bit trickier. First, if I have a car that's $27,000 and a house that's $270,000, how do you know which one's more? I mean, you might say just because I look at it and I can just tell. Or maybe you say because a car always costs less than a house, Mr. Otto. But really, how do we know that? It's all about place value, right? If I fill in these two numbers, the car was 27,000 and the house 270,000. I look at my furthest left digit, and then what place value is it in? Sorry. It's in the hundred thousands for the house and the 10,000s for the car. So this 2 for the car is worth 2 times its place value name, 10,000. And the house is in the 100,000. So it's worth 2 times 100,000, that first digit. So that first digit is worth a whole extra, 90,000. So it's longer, and this place value here is worth a lot more. And then 7, right, is worth really 70,000 because of its place value. Where it is in the number dictates how much it's worth. A lot more than the 7,000. But that leftmost digit really tells me, right? And this is starting to look like expanded notation. What does that mean? How do we do standard and expanded how do we do expanded notation? To write a number, we write each non-zero digit and we show it times its place value. So 27,000 in expand, we would take the 2 and show it times its place value of 10,000 plus parentheses 7 times its place value 1,000. Let's go backwards. Standard is what we normally use. So what would this be in our regular notation? Well, 5 times 1,000, 5 in the thousands place, 2 in the hundreds place, which means I've got 2 spots left, 8 in the tens place, which is worth 80, 8 times 10, and there was nothing left, so we fill in the rest with zeros. The decimal would be there, 5,280. So we've gone both directions, from standard to expanded, using a place value chart, and expanded back to standard. Let's talk on elapsed time. What if I'm doing an elapsed time, what if I start at 7:15 a.m. and finish at 11:10, and I ask how long it took? Earlier difference, right? We learned it's a little tricky when you get 11:10 and you're finding the earlier difference. You've got 15 here to take away from the 10. It doesn't work like a regular subtraction where you borrow from the 0 and make it 10, then make this 10. Then we're going to have to borrow or make that 0, then borrow 10. You don't do it the way we normally would do a subtraction problem. Instead, we're going to want to borrow from the hours into the minutes. See, on either side of this colon, we have 11 hours and we have 10 minutes. And these are really like separate sides of a problem. These are the hours and these are the minutes. And when I take from the hours side and move it into minutes, it's worth so much more. It's like, putting the American dollar into a country where that's worth so much different. The currency exchange is different. We exchange it into minutes, and suddenly 1 is worth what? 1 hour is 60 of these little minutes. Sort of like $1 is 100 little cents, right? It's a smaller version of measure. So I take an hour from my 11 and make it 10. That gives 60 over here. 60 plus the 10 I already had is 70 minutes. Now I can subtract, end up with 55 minutes. And I had 10 over here. So subtract the 7 and it's 3:55. Let's check AM, PM. AM, right? 12 AM to midnight. Or 12 AM is midnight to the moment right before noon. That's AM. And then PM is from noon to the moment right before midnight. So am I in the AM or the, well, in this case, we don't have to worry about that because it's just a how long problem. But let's see if we need it for next problem. What time is 2.5 hours after 10:43? A couple ways you can think about that. I think the best way is just to think it through, looking at like a clock, and you realize, well, 10:43 in the morning, let's just do the whole, 2 hours later, 11:43 pass into 12:43, and then I gotta change it from AM to PM. Okay, so that covers the 2-hour difference from 10 to 12. Haven't changed this yet. Then let's add a half hour. So you add another 30 minutes to this. That's where you maybe need to break out the pen and paper. Add your 30. We've already added the hours. You get 73 minutes, but we only show minutes in terms of 0 to 59. You don't show it over 60. So just like we borrowed into minutes so we could subtract, let's take from minutes into hours so we can properly show an answer. I take a full 60 anytime I borrow from the minutes side. And I pull it over to the hours, and what's 60 minutes worth in hours? 1 more hour. We only count 1 through 12 in hours, so after noon, the next hour is 1. And if I had 73, I took 60 away. How many minutes are left? 13 minutes. 1:13 p.m. is 2.5 hours after 10:43. Is that a reasonable answer? I'd say so. Let's take a look at what they say. Elapsed time problem, 2.5 hour difference. If we don't know the later time, but we know the earlier and the difference, it makes sense that we're going to be adding the 2:30 to the 10:43. Couple methods that are explained here. And there might be other mental math ways to solve problems too. I mean, if you can get the right answer, I love that. Then keep doing it the way you're doing it. Let's do expanded notation for C. Standard form for D, which isn't bolded, interestingly enough. I don't know why. And then let's do G and H because those are extra challenging. So C, D, G, H.